Okay, I'm going to talk a little bit about ammeters. Ammeters are the probe that we use to measure electric current in a circuit. The symbol for an ammeter is just a circle with a capital A to indicate it's measuring amps. Now, whenever we are measuring something in a circuit, we want to not mess with the circuit itself. And since we're measuring current, and current stays constant in series, we are always going to connect an ammeter in series, never in parallel. If you connect an ammeter in parallel, you can permanently damage the ammeter. And the reason for this is ammeters are set up so they don't change the circuit. To do that, we want them to have very low resistance. And in fact, an ideal ammeter has 0 resistance. So that means it's not going to affect the circuit at all as long as we put it in series. A real ammeter, of course, has a very small resistance. Everything has a resistance unless it's a superconductor, but it's very, very small. So let's take a look at how we're going to put these in a circuit. Here we have a very simple series circuit, 10 volt EMF, and a 100 ohm resistor. If we wanted to measure that current, we predict it to be 0.1 amps. But we are going to measure it with an ammeter. In order to do that, we need to connect that ammeter in series. So we're going to need to break the circuit. As you can see on the left, I've broken the circuit and connected the ammeter before that resistor. And since our ammeter has no resistance, it does not affect the circuit. And it's going to read the correct value. Same amount of total resistance, same amount of total current. It reads the correct value. Now, on the right, we have what happens if we try and connect our ammeter in parallel. Since our ammeter has very little resistance, basically 0, when we connect this in parallel around our resistor, it shorts out the circuit. We have a path of 0 resistance, so the current through this top path is incredibly high, and the current through the resistor is basically 0. So first of all, we've changed the circuit. We've changed the amount of current and voltage, or current going through things, and the resistance of the whole circuit, so that's not good. And very importantly, this incredibly high current is so high that it can permanently damage the ammeter. If your ammeter happens to not get destroyed by this process, then of course the value that it reads for the current is not going to be correct. It's not going to be the same as our circuit up here. It's not going to read 0.1 amps. So that's ammeters. Always connect ammeters in series because current is constant in series.